My name is HANIF AE 140046. Now I will explain about the introduction for our group assignment. For the introduction, the power system stability is divided into 3 parts. The first is steady state, second transient, and the third one is dynamic. Steady state is the ability of the system to bring itself back to its stable configuration following a small disturbance in the network. For the transient, stability is the ability of the system to reach a stable condition following a large disturbance in the network condition. And for the dynamic is the artificial stability given to an inherently unstable system by automatically controlled. The objective for our assignment project is to model the test system model of our system using MATLAB software to analyze the dynamic responses of the system following a disturbance and to solve the complex power system problems in a group within a limited amount of time. Next, we move to the assignment, the scope of the project. The scope of this project are listed as follows. The first one is the test system model used for this project for machine and bus system. The response of all generators are simulated using MATLAB. And the last one is the simulation models is model for transient stability analysis of the system.
Assalamualaikum. Today I will present about the literacy review for this project. Okay, in order to estimate the response of generator for stability analysis, one needs to know the concept of equal error accreditation. The equal error accreditation is concerned with the transient stability. The accreditation is very easy by using graphical method. Then it is for designing the transient stability of single machine or else two machine system against infinite bus. In equal accreditation, the real power transmit over a lossless line is given by this following equation. Consider the situation in which a synchronous machine is operating in steady state, delivering a power which is PE equal to PM when there is a fault occur in the system. For the clearing a fault, the circuit breaker in the fault section should have to be opened up. This process takes 5/6 cycles, and the successive post-fault tracing will take an additional few seconds. Next, when the fault occur at T0, the electrical power output is suddenly 0 while PM is uninterrupted. The differences in power must be accounted for by a rate of change of a stock magnetic energy in the rotor masses. This is accomplished only by an increase in the speed which results from the constant accelerating power PM. After delta 2 and delta T will oscillate until losses and the load damp oscillation at n T equal to 0. If delta 2 bigger than delta T, the generator losses stability because of PE less than the PM. Next, when a generator is applying power to an infinite bus over two parallel stationary lines, the opening of one the line will result in increase in the equivalent reactance and hence decrease in maximum power transfer. This is because depending upon the initial operating power, the generator may lose synchronism even though the load could be supplied over the remaining line under steady state operation. This is the for the graph for a stable, critically stable and unstable. That's all.
Bismillahirrahmanirrahim. My name is ZULHAFIZI. I'm going to explain about methodology. So, this methodology is about MATLAB function as code is known as dynamic model that provide the model of mechanism, model of machine and control system for performing tension stability simulation of a power system and build state variable model for small signal analysis and damping control design. So, the power system toolbar is MATLAB function that is used to build the power system design and simulation of power system. In order to complete our task, we have used programming method, which is the program according in MATLAB. Before using a programming method, we use the Newton-Raphson method to solve the non-linear equation. Okay, this is a data sequence of bus system. This is meant to develop data in MATLAB coding. To develop the data MATLAB coding, have three parts, which is this is first part data sequence of bus system, and then the second part is the coding of bus bar value. This coding of bus bar value insert the data for coding, and then use the value of bus bar to insert the being tested in the system. This selected of fault, which is bus bar 56 and bus 57. We insert 1.30 and second and 1.31 second. For the third part, which is the data is set to the declare the load input from data 50M from the M5. This is coding for the load input data from M5 data 15M. The next, after the coding is inserted in the MATLAB, then the coding to obtain the result of plotting graph for the machine rotor angle with COI reference and machine speed with COI reference. This is coding for plotting the graph machine rotor angle with COI reference and then machine speed with COI reference. That's all for me.
My name is Syafiq bin Zainal ABIDIN, AE 140023. So today I will present the result and discussion. First of all, I would like to tell you that this project has 4 cases reported to be demonstrated in the system response following the fault in the system, which is stable cases, critically stable case, and also unstable case. For the first one, I will show you the stable case result. If you can see here, these figures show the response of the system following a fault for stable case, where the fault clearing time is set to 0.01 second after the fault occurrence. For this case study, fault is applied at 1.07 second and cleared after 1.08 second after the start of simulation. This can be seen at the figure. So most of the generators mirror for this graph. Most of the generators show similar time trend of generator rotor angles, where only one is different up here, and the highest peak of the alternator degree is 150 degree here, while the lowest peak is at negative 2430 here. So after fault is clear after 1.08 second, all generators settle to new equilibrium point respectively. This behavior can be observed after 7 seconds here from the start of simulation. This implies the system is stable if the fault occurs at bus 139 to 140 is cleared 0.01 second after the fault occurs. It is for critical stable case. This is a graph that shows voltage magnitude measured at the fault bus for critical stable case. If we can see, the fault is applied at 1.08 second and cleared after 1.09 second after the start of simulation. And for the next graph, which is that show the rotor angle response. Most of the generator show similar trends of generator rotor angles, just like the graph before. And we can see that the highest peak for rotor angle response is 150, and same for the lowest peak, which is negative 2430 degree. After fault is cleared, after 0.01 second, all generators settle to a new equilibrium point respectively. Moreover, the peak-to-peak values of all response are also similar like the previous case. That implies that the system is still stable if the fault occurs at bus 139 to 140 is cleared after 0.01 second after the fault occurrence. For the last graph, it is the graph of unstable case. This figure shows the response of the system following a fault in the system, which is cleared after 0.01 second. And the next one is figure of rotor angle response. For this case, fault is applied at 1.0 second and cleared after 1.10 second after the start of simulation. The switching sequence can be observed in the previous graph. And in this case, most generators show similar time trends of generator rotor angles, but only one showing increasingly linearly. Okay. These two groups of generator oscillates in separate way after 0.01 second after the start of simulation. It shows that the system did not settle to a new equilibrium point following the fault in the system. The time when the system starts to accelerate and decelerate in separate way is much faster than the case before. This implies that the system is unstable. Thank you.
Okay, Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad AZLEE bin AMRAN, AE140156. So I will continue about conclusion. So in a conclusion, this report presents transient stability analysis test system model for the fault occur between bus 139 to 140. Our group has achieved the objective, which is we know how to analyze the dynamic response of the following disturbance. Other than that, we know how to use MATLAB to test system model of power system. With this project, many knowledge about coding using MATLAB that we got. We also work as team to discuss about stability, marginally unstable, about fault that occur at bus system, and so on. Protection in electrical system are needed to ensure that any device or component does not damage if failure occur. Finally, this project makes us more interested to electrical engineering, which is more protective system device. So that's all. Thank you.